Hello, Facebook. Welcome to the Facebook Live tonight on why not cross multiply and divide. All right, all you middle school teachers, bring it. Invite your friends. Let's chat. Why not cross multiply and divide to solve proportions? I mean, it works so slick, right? Just tell the kids to cross multiply and divide. The kids just do it. They all get correct answers. Maybe day one they do. So what happens? You're a good teacher. You have a good heart. You clearly show kids this is a proportion. This is what you do. The method that you use to solve a proportion is cross multiply and divide. The kids seem to get it. They seem to be successful. Now, when the numbers get crazy, it's going to depend on if the kids are decent with doing the multiplication or doing the division of those crazy numbers. So that's going to kind of play in. But for the most part, they do pretty well. Until the next sort of rational thing shows up. Welcome, everybody. I'm seeing lots of people get on. Sweet, we're having a good group tonight. Until we do something that looks kind of like it. For example, what if we start, hey, Velvet, what if we start adding fractions or subtracting fractions or multiplying or dividing? Like it almost doesn't matter what's in between the two fractions. Now we have two fractions and, hey, they might be doing the butterfly from last year. Right? When they were teacher last year, or maybe you taught them how to compare fractions. Well, there's a rule. We got the butterfly. Let's see. Now we got cross multiply and divide. I wonder which one you do when. Oh, wait. Now we got find a common denominator. Let's see. Is that when we're adding, subtracting, or multiplying, dividing? Maybe it's when the equal signs. No. And now we're going to multiply straight across, and then we're going to invert and multiply. Okay. So hey, Mary. So which one do you do when? Now, some of your students can hang on to that. You did. Right? You can hang on to which rule to do when, which sort of steps go in which rule, and in which case you're going to do which rule. But how well do your students hang on to it? Maybe yours hang on to it for a while. Obviously, you're a good teacher. Again, you have a good teacher heart. You're doing your best to make sure that they know which rule to do when. What if instead we took a completely different take? What if instead we ask kids to actually reason through solving a proportion? What would that even look like? What would that mean? Well, tonight I want to give you a brief glimpse into what I sort of found later in life that I was like, whoa, how come I didn't know this was a thing? May I share with you that thing? And it's called a ratio table. And we can use ratio tables to reason through proportional reasoning problems and create proportional reasoners, literally that our kids get better and better at reasoning proportionally, while they're also getting answers to solving proportions. Not just getting answers to solving proportions, but we're actually helping them think and reason proportionally as they solve them. What could that look like on a ratio table? Well, let's do a little bit of work with that tonight. So I have a surprise for you at the end, so hang on, everybody. I want to make sure that you hang on till we launch the surprise to help with even more ratio table fun. All right, so let's see. No place for butterflies in math class. Amen. Or alligators, all the things. Yeah, totally. Okay, so let me change my input just a little bit. Let's take a look at a ratio table and what it means. So the first thing that I want to really emphasize tonight is that we have to use context. Now, they can be mini contexts to help kids sort of think and reason proportionally, but context, especially when we begin, is so important to help kids sort of reason through what's going on. So let's start with a contextual problem. What if you started with, we've got some sort of club is raising money. I don't know. We've got a group running a bake sale. Somehow some kids are going to sell some brownies. And so the deal they've got is that you can, for $6, you can get 8 brownies. Anybody? Brownies? I haven't done sugar all week because I'm trying to get off the whole holiday sugar rush. And so brownies are sounding really good right about now. And so what if this is the deal? For $6, you can get 8 brownies, and somebody walks up to you and says, sweet, how many brownies can I get? This is what I have. I've got $40.50. I'm going to support your group. How many brownies can I get? So we start with a context, and then we help kids sort of think about, all right, well, if I've got that $6 and I can get, let's see, let me put dollars here, or money, and then we're going to put brownies here. And so I've got $6 can get me 8 brownies. That's the beginning of a ratio table. That's sort of what we've got. But now our goal is to be able to sort of work up to, and I'm going to make this a long ratio table, work up to where we are actually spending $40.50. So now the question becomes, what can we do to get that 6 up to that 40.50? Like, wow, what can we do? Now, a beginning proportional reasoner, developer, a kid who's beginning to solve proportional reasoning problems might begin with something who sweet. Okay, that's funny. Thanks, Kay. I'm smiling at your 9-year-old. 9-year-old. Yeah, that's fun. Totally fun. Okay, sorry. Where was I? So a beginning solver might say 6. What are some things I know? Now, this is what we want kids to do. We want them to use what they know. A beginning solver might say, well, I can double those. So for $12, I could get 16 brownies. Then they might think a little bit and they might go, 12, that's not very close to 40, 50. What else do I know? Oh, I know I can multiply by 10. So maybe I'll sort of scale by 10. And so if I've got $60, then that would give me 80 brownies. That's too much. Okay. All right. Well, I've got some boundaries now. Okay, cool. Well, what else do I know? Well, maybe I'll go back to doubling. So let's see. What if I double the 12? That would get me $24, would give me double the 16. That would give me 32 brownies. Okay, I'm getting up there. Let's see, what else can I do? Well, I might then add that 12 and that 24. And so I would add the 16 and the 32. So let's see, 12 and 24, that's $36 would get me 16 and 32. That's 48 brownies. Okay, 36. Hey, 36. Now, what we want to kind of do is, as the teacher, we want to sort of nudge in on students and kind of help them think about how close are you? Because students might just sort of like throw down, they might keep doubling. They might go way over and not even realize it because they kind of lose sight of their goal a little bit when they're beginning solvers. So we would kind of help them think about, like, how far do you have to go? In fact, I'll sort of put down here, how far away are we, or how close are we? Either way we can ask that question. And so from 36 to 40.50, well, that's just what? $4.50. Okay, so that's interesting. Like, what can we do $4.50? So we kind of wanted to look at the relationships in the ratio table and wonder how they could get from any of the sort of things in the money. Is there something they could do to get close to kind of this missing value of what's missing in between the 36 and the 40.50, that $4.50? Well, some kids might say, from that original 6, I can cut that in half. And so if I divide that by 2, then that would be $3. Okay, so $3 is close. That's sort of getting me there. And then I would have to divide that by 2. And so that would give me 4 brownies. Okay, what do I still need? So that would be $39, right? And for $39, then we've got what, 52 brownies? All right, okay, let's see. What do we still need? Remember that all-important question, how close are we between that 30? Hey, we're what, $1.50? $1.50. Is there anything up here that could help me get to, $1.50? Dun, dun, dun. Can I just divide that in half, divide $3 in half to get to that $1.50? Then I would divide the 4 brownies in half. That's easy. That's just 2 brownies. Woo! Now, if I add that $39, remember we went there because we knew we needed that. So if I add that $39 and that $1.50, I get to the $40.50. And so how many brownies do we get? Well, what's 50 plus 2? That's just 54 brownies. Sweet! And we have solved this proportion. Now, they might, I'm even suggesting at this beginning point, they might not even know this is a proportion. We're literally just starting with what we know, and we're using relationships to get more sophisticated. Now, you might look at that and you might go, Pam, I might rather have my kids just cross multiply and divide. I mean, maybe that was a lot of work we just did. However, as we did that lots of work, your students building proportional reasoning. Now, I would want to nudge students using problem strings. And so let me write that down here. Problem strings. If you're not sure what a problem string is, I'll talk more about where you can learn more about those later. I might want to use problem strings. I would want to use problem strings to help my students get better at being more efficient problem solvers. So I might expect a less beginning student to sort of start with the same idea. I've got dollars and I've got brownies, and for $6, I can get 8 brownies. And again, their goal is to think about getting up to that $40.50. Well, a more advanced solver might say, 6 to 40.50. Well, I know that 6 times 6 will get me to $36. Bam! Look how close I got. And so then I would scale the 8 brownies times 6 as well. And that is 48 brownies. And then how close are we? And again, then I might sort of do that same sort of thing we did where we had the 3, and that was $3 for 4 brownies, and then the $1.50 for 2 brownies. And instantly then I'm at that 54, not instantly, but a whole lot quicker. So we would expect students to use more and more sophisticated relationships the more and more we work with them to sort of look at their goal and think about what they know and build their multiplicative reasoning, which is going to be really important as your students are wanting to reason proportionally. We know that proportions are all about multiplicative relationships, not about additive relationships. It's not about thinking about if I add $2, then I add 2 brownies, right? Like that, in fact, that won't even work because $2 doesn't get you 2 brownies. $1.50 got you 2 brownies, right? And so we need to help kids realize that it's not this additive relationship, but it's this multiplicative relationship as we scale that beginning ratio. So it might look a little bit arduous to start with, and you might be like a little bit unsure, like, I don't know, Pam, my kids are taking a few steps. But in that, helping them use what they know, kids gain confidence. They're like, oh, I don't have to memorize a rule. I just have to use what I know. And then you step in and nudge using problem strings to help them get more efficient and sophisticated, like that the second strategy we showed. But we can get even better. What if I, again, start with that money and brownies, and I say I've got the $6 and the 8 brownies. A more advanced problem solver might say, hey, I'm going to take that to $3 for 4 brownies. I'm going to cut it like right away. Okay, all right. Now let's see. I'm trying to get up to that 40. Ooh, I could scale that times 13. 3 times 13, that's 39. What's 4 times 13? I might have to do a little work there. Let's see, is that 52? Yeah. And then what am I still left with? Oh, then all I need is that 1.5, and I could get that. Let me clear this up a little bit. I can get that from that 3 again to the 1.5 and 2 brownies, and then add those together, and then I have the 40, 50 for 54 brownies. And so that sort of answer to the proportion, well, actually, let me do it this way. After we've solved several contextual problems, and honestly, I would recommend that you do problem strings to help kids get really good at some contexts. Like use a few really nice chosen contexts and do a lot of problems with them. So I would do a lot of brownie problems. I wouldn't just ask the $40.50, but I would do a problem string where there's several problems I would ask about this 6-to-8 ratio. Then at some point, after we've done a couple of contexts and lots of problems, then I would say, hey, when I gave you that problem, $6 gets you 8 brownies. How much brownies can I get if I spend 40, 50? Then at that point, come in and say, hey, guess what, guys? That can be represented by 6 to 8 is equivalent to 40, 50 to that unknown. Like we could represent these contexts that we've been working on with this thing called a proportion. And then I introduce a proportion. You guys, we call that just in time, not just in case. Nope, not just in case. Just in case means I do it up front and I make sure that you've got it so that you have it when you need it. Instead, I want to get kids involved and in it and thinking and reasoning and building their proportional reasoning, and then come in and say, just in time, hey, I could represent that problem from the get-go like this sort of decontextualized, that's what the standards mean, the context isn't there, decontextualized proportion. And you could solve it the same way. You guys, if you see a proportion that looks like this, you can solve it the way we've been solving all these contextual problems. And in fact, teachers, I would recommend, so first, do lots of context problems. Few well-chosen contexts, lots of questions about those well-chosen contexts. Then show kids this, that it could look like this in a proportion. Then give them a naked proportion and say, what could be the context? So then you might give them something like, oh, let me just kind of look over here. That's a lot of brownies, yummy. Pam, are these recorded? I'd love to share this with my 6th grade teachers. Carrie, yes, we record all of the formal Facebook Lives, which this is one of them, as formal as Facebook Lives ever get. And then we put them on my YouTube channel, which is Figuring Math. You can look that up, or you can just Pam Harris Math will totally bring up the YouTube channel. When you get to the YouTube channel, look for the playlists, and one of the playlists is Facebook Lives. So you can totally look for the Facebook Lives playlist. There's lots of playlists there that you might want to show your fellow 6th grade teachers. At least I'm assuming maybe you work, maybe you're their coach. I don't know. But plenty of good learning that we stick in there. Oh, and thanks, Kim, for throwing that in there. Probably somebody might throw in a link in a minute. Okay, so first, some really well-chosen context with lots of problems. Then show them the proportion. What comes after that? Now show them a naked decontextualized proportion and ask them what could the context be. Like you might give them something like this. You might say, hey guys, what if I gave you, what if I gave you this proportion? That's a 0. That's a 2. What if I gave you that nasty proportion? What context could that be? That's the first question. Don't even ask them to solve for X. Just say, what could the context be? Well, now I'm suggesting that you would have done some context like this so that the kids are sort of like, they can kind of connect it with some ones that have made sense. You guys, let me share with you a great context for problems like this. Quick drink. Quick Ricola. My throat's hurting. Could we have done some problems with kids where they could say, ooh, I was in the bulk food aisle and I bought 0.8 or 0.8 pounds of, like, pick your candy. I don't know, chocolate covered hazelnuts. That's what I like to buy. And it cost me $2.50. That'd be a really good deal for chocolate covered hazelnuts. Maybe it needs to be gummy worms or whatever. It could be peanuts, whatever it is that you go buy in that bulk food aisle where you get the scoop in there and you put it, you put the bag under and pull the thing and all the stuff in the bag. And then that bag gets weighed and then a sticker gets on the bag where it says you bought 0.8 or 0.8 pounds of whatever it was for $2.50. What if I want to get 5.6 pounds? What if the next time I go in, I put the bag under there and I pull the thing down and like it all like fills up the bag and all of a sudden I have 5.6 pounds? How much money will that cost me? Now, can kids solve this problem? First of all, first question you ask them is, what could the context be? Have them think about the context. And then now go ahead and solve. How much money would that cost? Now, notice that I showed you some horizontal ratio tables, but ratio tables can also be vertical. So kids could say, well, I'm going to go ahead and think about that I bought 0.8 pounds and it cost me $2.50. That could be a ratio table that they set up. And then their goal is to get to 5.6 pounds. Hey guys, where would the 5.6 go? Does the 5.6 go over here? Does the 5.6 go over here? It's connected to the pounds, right? And they've already thought about what those proportions look like. And so they're like, oh yeah, so it's the pounds. So I need to find 5.6 pounds. That's my goal. Oh, gravy. How can I get from 0.8 to 5.6? So again, let's kind of run this a little bit. What might kids do as you first start working with them? And then how can we nudge them a little bit more? Let me kind of look at some of the, Kim, thanks for putting the YouTube channel in there. Perfect. Laura, starting with the context is so important. Totally agree. Ooh, Stephanie Felton, nicely done. 0.8 gallons to $2.50. Sure, that could totally be nice. That's like a good gasoline price right now, I think. Is that right? 0.8 of a gallon to $2.50? It's not too bad for a gas price right now. But might even, that'd be a really cheap milk price. Anyway, gallons was totally good. Great context, Stephanie. Maybe some of the rest of you guys could be thinking if you can come up with any other context for that naked ratio table. All right. How could a beginning solver get from 0.8 all the way up to 5? I mean, and then kids will do some things like double. So if I double the 0.8, then I get to 1 6/10. Now, you might need to do some work with kids with decimals. I'm not saying that they can dive right in here if they haven't ever done any work thinking and reasoning about decimals. We'll probably want to do that. If you want more of that, I have a surprise for you at the end where I'll tell you all about where you can do your next learning, all about how to use ratio tables. So then I would double a $2.50. Hey, that's nice. That's just $5. Let's say I might double again. And so let's see, $1.60 is that $3.20, or we're in pounds over there. So that's fine, 3.2 pounds. And then I would double that again. And that's nice because that's just $10. How close am I? Remember that all-important question, how close or how far away are we? Well, let's see, 3 to 5.6. I don't know. What do we need? 2 something-ish? I mean, I guess we could just like add let me clean that up a little bit. If we added the 1.6 to the 3.2, what would that get us? Let's see, 3.2 and 1 is 4.2, and that leftover 0.6 is at 4.8. Yeah, so a kid could think about that, and then I would add those together. Whoo, that's not too bad. That'd be $15. Well, I'm getting close. Let's see, how far are we? How close are we? What do I still need? Ooh, it still looks like I still need, let's see, I could think about that kind of like 4.8 to 5.6. Let's see, 4.8 up to that friendly 5. That's just 0.2, and that's just 0.6, right? And I'm going kind of fast. I wouldn't be telling kids how to do this. I'm sort of hoping that I've done work enough with kids that they can the kids would think about these relationships. And so is that just, is that just hey, that's just, oops, not dollars. That's just 0.8, right? Hey, 0.8. I'm just 0.8 away. All I need is 0.8 or 0.8. Whoa, we've already got that. Nice. So all I need to really do is add to that. If I've added 0.8 pounds, I need to add another $2.50. So what would that be? What is $15 and $2.50? Is that $17.50? And we just solved that gnarly proportion with crazy numbers, thinking and reasoning, using relationships that we own, that the student owns. Y'all, these weren't even very sophisticated relationships. We're just doubling and adding and doubling and just sort of like using kind of what we have in the table. So anybody curious what a more sophisticated strategy, a more student who's using slightly more sophisticated relationships might do? Let's clean that up a little bit. Now, maybe pause the Facebook Live. Maybe say to yourself, I wonder how I would solve that. Like Pam's talking about more sophisticated learners. I'm a more sophisticated learner. Like what are, now I'll tell you guys, when I first started using relationships and connections I owned instead of memorizing rules and mimicking procedures, I wasn't all that sophisticated. It took me a while to build my own reasoning, but it was so worth it because now I can hit any problem and I just reason through it. What I don't do anymore is go, which rule was that? And reach for, nope, not anymore. Now I just like reason about the problem. It's not about reaching for rules. It's not about trying to memorize steps and mimic what the teacher showed. It's about using what I know. What do I know? And then working my way there. And then the teacher helping me with problem strings. Let me write that down again. With problem strings. And if you don't know what those are, I'm going to tell you in a minute how to find out more about those. To help the kid get more and more sophisticated. Like, how can we do that? All right, so I've got pounds and I've got money. We started with 0.8 of a pound and $2.50. What would a more sophisticated learner do to get up to 5.6? And let's see. Yeah, I'm just looking at the time. I think we'll just skip right ahead to the kind of the most sophisticated one that I was thinking about. No, do I want to do that? Yeah, probably. Could a kid think to themselves, you know what? I'm going to scale this up times 10. What? Why would they do that, Pam? Well, now I've got 8 pounds for $25. Is that right? 8 pounds for $25? Yeah. Nobody's put a comment. You guys are all staring at these decimals like, whoa, those are intense. Pretty cool, right? So now that I'm at that 825, a kid might say, how do I get from 8 to 56? Well, 8 times 7 is 56. Now I got to scale that quarter times 7. 7 quarters, right? 25, that's like quarters. If I had quarters, like literally the coin quarters, and I had 7 of them, 4 would make $1. 3 more, is that $1.75? So if I've taken 25 and I've multiplied by 7, is that 175? Yeah, think so. And so now I've got 56, but I need 5.6. So now I just scale down, divide by 10, and is that just 1750? Bam! And we have solved a cranky proportion using slick relationships and connections with far more understanding, far more reasoning, far more confidence than if I were to cross, multiply, and divide those numbers. I mean, those are pretty gnarly for cross, multiplying, dividing. I don't think I want to do that. Look at all of the potential errors that could happen as kids do that multiplication and then that crazy division. Or they can just use what they know, relationships and connections that they own. Bam! Thanks, Bethany. Is more sophistication always just bigger jumps? No, not necessarily. Sometimes it actually can be smaller jumps. I don't have an example of that one today, but it could. Kyle, I know who you are, so I'll give you the bam answer. Sometimes it means that I take half of something and then I can scale that really nicely. So it's not always, but it is often bigger jumps. One of our goals is bigger, fewer jumps. That's a sign of sophistication, but it's not technically always, but often it definitely is that. So y'all, here we have some fairly cranky proportions that students just solved thinking and reasoning using what they know, you might be a skeptical real teacher where your students have to take real stupid high stakes tests. Now you know how I feel about the tests. I get it, right? You're looking at that and you're like, Pam, you created this to work out so nicely. They don't work out that nicely. I mean, everybody worked out nicely. What did we get for an answer? We got 1750. I mean, I don't know that that's all that nice, right? However, I have looked at many high stakes tests. I've looked at many solving proportions problems on many high stakes tests. I have yet to see one that doesn't work out that nicely because the test writers are smart. They want to sort of reward kids who are thinking and reasoning and make the other kids kind of work for it. Like if you're not going to think, you're just going to follow some rules, then we're going to make you work for it. But if you're thinking and reasoning, we're going to give you this slick path to just like be able to solve it because they don't want to, they want to encourage thinking and reasoning. At least I'm going to give them the benefit of the doubt that that's why they write it that way. So I would challenge you, go look at your high stakes tests and see what you find. See if you can find proportional reasoning, solving proportions problems, and check out how if you use a ratio table to use what you know and scale, that they're actually really pretty solvable. Again, the best part, so I need that, right? I need good scores so I can keep doing what I'm doing and people stay out of my business. So that's important. But even more important, we're building proportional reasoning. We're helping our students reason more and more sophisticatedly, which is so important. Okay, cool. Let me look at my notes and make sure I've done everything I wanted to do. So let's review. Context first. And choose a couple really nice ones and ask lots of questions about each one. Lots of ins and outs. And how do we do that? We do that in a thing that we call problem strings. That's an instructional routine that is really handy. Then use, in fact, my second bullet was use problem strings. Okay. Can you tell I'm excited about problem strings? And then third, then show how to represent. So this is the teacher stepping in and saying that in our culture, we can proportion. That in our culture, we can set up these. We've decided that we can label them as that thing to this thing is equivalent to that thing to that thing. So this comes in later. Then we say, hey, this is how it could look. And we model sort of the representation. Students can say, when we solve a problem like this, it can look like that. Okay. All right, cool. And then you do that. You go back to you keep doing problem strings and keep using context and you keep building. And as you do, as you solve those problems, you say, hey, we could represent that with this proportion. Then come in. Let me just make sure I'm looking at I can't even read my notes, you guys. What did I say? Oh, yeah. This is the decontextualize. So I guess I could try to spell that decontextualize. Then I give students something crazy like 0.8 to, and I don't quite remember what the numbers were, to 250, and I've got 5.6 to X, then give them the naked one and say, what's the context? Have them provide a possible context. They're making sense of what that proportion means, and then go ahead and let them solve those crazy problems. So you're going back and forth between context and decontextualize, between solving and representing, and pretty soon students can see either. They can see a proportion problem in words and know how to represent that in a proportion. They can see a naked decontextualized proportion and they can put context to it if they need to, but they also know they can just throw that on a ratio table, use relationships and connections to solve that proportion. Make sure that when you're doing ratio tables that you use both vertical and horizontal ratio tables. Make sure kids see both. If you know my book, Lessons and Activities for Building Powerful Numeracy, that's that one right there, then you know that in that book, I only ever do horizontal ratio tables. You might be like, but Pam, I thought horizontal ratio tables, that's all that's in your book. You know why? Totally about space. Like we can get more on the page. So I make sure when I present, when I do stuff live, that I always do some vertical ones to make sure that teachers realize that we need to have both vertical and horizontal. And then lastly, a thing that I want you to think about is that in a huge way, it would be great if you did some multiplication and division with your students first, and then in between. Now you might be like, Pam, multiplication and division. I mean, they did that in the younger grades. I'm a middle school teacher. Yeah, I totally get it. I don't mean with the algorithms. I mean thinking and reasoning. Are you ready? On ratio tables. I want you working to help students solve multiplication and division problems using ratio tables as the tool, so that then, how do I say this? Because those will all start with a unit rate. You guys are middle school teachers. You know what a unit rate is. If I'm a multiplication or division problem, that's all about unit rates. Then when I move to non-unit rates, the land of the middle school, where you guys are solving those proportions with ratios, not just unit ratios, but non-unit ratios, then students can just slide right into using the ratio table to solve proportions. But then I would also do those in between. So I would work a little bit on multiplication division and do the contextual problems with non-unit ratios, do some multiplication division in between, do some more non-unit ratios. Just keep building students proportional reasoning all year long. Take the long road, the long view of building that proportional reasoning. Typically, your curriculum will help you do that. Take the long view, because it'll have you solve proportions. They typically start with naked ones. Don't do that. Then they'll have you do it with similar figures, where you're solving for the unknown sides of similar figures. They'll have where the sides are corresponding. They'll have you solve different kinds of proportional reasoning problems, like sales tax and like percents. So all of those different opportunities throughout your curriculum just help you be able to keep building with your students on their proportional reasoning and their facility with getting more and more sophisticated as they use that ratio table for a tool. All right, I promise you guys a surprise. Facebook Live is a short, quick, let me give you some big ideas, some things to chew on. Where do you get the down and dirty? Where do you get more information? I talked about using multiplication division on ratio tables. Where do you learn about that? May I offer to you a free webinar where I can slow down a little bit? You watch me go through this. In a webinar, I slow down. We do more examples, take lots of questions. So I invite you to join me in a free live webinar Friday, January 22nd at 8 p.m. Central Time, or Saturday, January 23rd at 11 a.m. Central Time. Figure out your time zone, and we are going to dive into the ultimate math model you've been waiting for, which is ratio table. That we're just going to totally focus on all things ratio tables in that webinar. You'll need to register. In order to register, let me put that up a little bit. I'll come back and get your comments in just a second. In order to register, here is the link, mathisforgettable.com, which should be saved in your browsers, mathisforgettable.com. Tons of good things there, /webinar21. Somebody will throw that in the chat. Click on that, register real quick. Register, because when you register, A, you can get in, you'll get the link. B, you'll get a handy dandy note-taking guide. And you'll also get access to the recording, so that I don't remember who it was, but was going to show their fellow sixth grade teachers. You can show your sixth grade teachers all the things. And so register for that, and then you have access to all the goodies that come with. All right, let's see. Kay said, our district is practicing for state testing this week. Daughter came home very excited that she did her whole test review with ratio tables and got them all correct. Woo, Kay! You are making the biggest difference of all with your own kid. That is amazing. Such good news. Brittany, getting kids to think about relationships with numbers and reason through problems will help students with high-stakes tests. I've seen it work beautifully. Thank you, Brittany. Thanks for the testimony. It's great to have some of our expert teachers who have been learning. They've been taking the proportional reasoning online course, or the multiplicative reasoning online course. They're learning all about how to dive deep into multiplicative reasoning and proportional reasoning. So cool to have experts on with us tonight. Thank you. Yay, Carrie. That's awesome. There's the link. Sweet. Looking forward to it. Pam, excellent, Colette. We'll see you there. Thanks so much. I was faking my math excitement for students to get them excited about math. Since discovering your videos and everything else, I'm really excited about math. That's awesome. Bam. Like that. You made this whole Facebook Live worth it tonight just for me to hear that. I appreciate you sharing that, Kay. It's so true. In a huge way, that was kind of used to be me. When I was a high school math teacher, I kind of got excited, not really about the math, but it was the kids. I liked teaching and I liked being involved. In fact, little known story. Oh, I'm over time. I'll say it quickly. I try to keep these short so people know that if they tune in, that it stays fairly short. I was a coach. So I coached high school basketball. Loved coaching. And I would say back then, if I could coach or teach, I would coach, hands down. Y'all, I'm not so sure anymore. They might be more even now. I'm so excited about the relationships that I can form with students, because now the mathematics is all about relationships. Hope you guys join us on the live webinar. Thanks so much for tuning in tonight. Please share the recording. It'll show up on my Facebook page. It'll also show up in the YouTube channel. Please share that so we can spread the word that math is figure-outable. Hey, and maybe catch the podcast on Tuesday, the Math is Figure-Outable podcast. But really love to see you on the webinar. Any more questions, concerns? Looks like we got it. All right, take care, everybody.